An electric motor spins the hard drive's disk at exactly 7,200 revolutions per minute. The circuit board keeps the speed constant. And here's the crucial part: the actuator arms that hold the read-write heads. The ends of the arms are split, and right in the middle ride the disk platters. But the heads never actually touch the disks. The space between the head and the surface of the disk is 5,000 times thinner than a human hair. The heads float on a cushion of air created by the spinning disks. An absolutely essential cushion that prevents the head from crashing on the disk. And what a crash it would be. Talking about a crash is not only a metaphor. At these tiny scales, the weight of the heads really compares to the weight of a 747 airplane. A 747 airplane packed with 100,000 passengers, flying at 60 miles per hour, 1/100th of an inch from the ground. Ouch. There's no friction to slow things down, so the arms can move the heads to write or access data up to 60 times per second. The engine that drives the arms is invisible because it's an electromagnetic system driven by two forces of nature: electricity and magnetism, which makes the arms move back and forth across the disk at lightning speed. That's it for the components. Now here comes the data. The data is stored inside tiny concentric tracks on the disk's surface. During manufacture, up to 200,000 of these tracks are created on the disk. Each track is divided into sectors. A map of the tracks and sectors in the printed circuit board tells the heads exactly where to read or write information. The surface of the disk is smooth and shiny, but look closer. It's way more complicated. A magnetic film on the surface memorizes all the information. The heads magnetize microscopic sections of the film and store the data in a sequence of ones or zeros. Each one or zero is called a bit. The value of each bit is determined by the orientation of its magnetic field, plus or minus. And it doesn't take long for the bits to add up. One high-quality photo can take up 29 million bits spread across 12 different sectors of the disk. This sounds incredibly massive, but in reality, a stupefying quantity of bits can fit in an extremely small space. Each square centimeter of the disk's surface holds 31 billion bits. Now that's space-saving. A hard disk stores and recovers a phenomenal amount of information at speeds that defy comprehension. Using the power of magnetism, the shiny surface of a hard disk can store the contents of several sets of encyclopedias, or hundreds of thousands of images. Easy. The hard disk really is an amazing, shrinking machine, squeezing mountains of data into little bites with a single key stroke. This masterpiece of engineering has really stretched the boundaries of physics, bit by bit. Coming up.
Compact discs are copies made from an original glass master disc, A thin plate of glass is first placed in this unit, which brushes the surface to perfectly clean it. The machine starts up. Cleaning is done with deionized water and a small goat hair brush. The excess water is eliminated by the rapid rotation of the disc. The disc then goes into this surface analyzer, where a laser beam inspects the cleanliness of the surface. At this stage, two chemicals are applied, a primer and a photoresistant coating. This operation is done at a temperature of 21 degrees centigrade and lasts 3 minutes. The disc is delicately retrieved from the apparatus. Then the photoresistant coating dries in an oven for 30 minutes. This developer has two spouts. One applies deionized water and the other sprays a solution to develop the data etched on the glass. The information is now engraved on the disc. The disc is placed in this metal coating equipment. The next step consists of applying a thin coating of nickel and vanadium. This electroforming process results in the master from which discs will be made. The etched glass is immersed in a chemical solution for 70 minutes. Then the plated piece is removed, thus obtaining a die. This die is sent off for finishing. It is stamped out into the desired shape. The excess material is later recuperated for recycling. Following on, the compact discs will be fabricated from this master unit. Here we clearly see the stamping out technique. The master is taken out. A technician peels off the film, which protected the data etched onto the die. Following a visual inspection, the die is sent to the pressing department. The die is delicately installed in the mold, which will form compact discs. Discs are made from a very special plastic called polycarbonate. The mold is closed and liquid polycarbonate is injected into the die. It comes out as a small, hard, translucent disc. It is now ready to be metal coated so that it can be read by a compact disc reader. A robotic arm lifts the disc from the mold and places it on these supports. This metallizing process is extremely short and very simple, taking but a second. It consists of covering the plastic disc with a very thin coating of aluminum. Here we see the inside of the mold, where the aluminum coating is applied. In this facility, almost everything is automated. This allows for the production of over 100,000 compact discs per day. Protecting the surface of the disc is essential, so a coat of varnish is applied, which also allows silk screening to stick well to it. Ultraviolet lamps very quickly dry the varnish. And here in the pressing room, they apply the label. This step is also very fast since the machine prints 70 discs in 60 seconds. Once the silk screening is completed, the finished discs leave for packaging.
Information in a computer is stored as thousands of zeros and ones called bits. On a CD-ROM, bits are represented by microscopic holes and bumps called pits and lands. When a laser beam is reflected off of these tiny hills and valleys into a photodiode, they turn into an electrical pulse that a computer recognizes as a stream of zeros and ones, thus recreating words, images, and sounds.